Welcome to section 9.17. This is the 89th session of the CISSP exam prep series. In this session, we'll unpack containerization. What is it, and how does it differ from traditional virtual machines? Why does it pack so much more onto a single server? And what makes containers so portable and flexible? Why does this matter beyond the exam? Because containers are how modern software actually ships. Picture a streaming startup that pushes updates several times a day. Each small service rides inside its own container, identical from a developer's laptop to the production cloud. When you understand what a container shares and what it isolates, you can secure that pipeline instead of just trusting it. So what is containerization, and how does it differ from virtual machines? A traditional virtual machine runs a full guest operating system on top of a hypervisor, and each machine usually carries just one main application. That means the same operating system gets duplicated over and over, which wastes resources. Containerization, sometimes called operating system virtualization, strips out that duplication. Each application goes into a container holding only what that specific app needs, while the shared operating system parts live once in a common container engine. Some setups drop the hypervisor entirely and let containers call on a shared set of binaries and libraries. Think of apartments in one building sharing the plumbing and foundation, instead of everyone building a separate house. Why does containerization pack so much more onto a single server? Because you are no longer paying the overhead of a full operating system for every workload. By sharing common components instead of copying them, a single physical server can host far more applications than classic hypervisor virtualization allows, on the order of 10 to 100 times the density. Picture a parking garage. Give every car its own private lot and you fit a handful. Stack them efficiently in shared levels and you fit hundreds in the same footprint. What makes containers so portable and flexible? Applications get wrapped in application cells, also called application containers. So the same packaged software can run on almost any operating system. That portability is the whole point. A container built once behaves the same wherever it lands. The technologies grouped under containerization vary in the details. Some allow several applications to share one container, while others keep it to one app each, and many let you tune exactly how much containers are allowed to interact with one another. Think of shipping containers. The standard box fits any truck, train, or vessel, and you decide how tightly the cargo inside is sealed off. So let's bring it together. Containerization removes the wasteful duplication of running a full operating system per workload. Instead, each app carries only what it needs, while shared elements sit in a common engine. That efficiency delivers dramatically higher application density on the same hardware. And because containers are portable and configurable, the same package runs almost anywhere, with control over how much the pieces interact. Grasp this model, and the cloud and DevOps material later in the series will click into place. The MCQs covering all the topics and concepts from this session are available on RooCloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.